I'm Georgios Katsoukis and assistant professor at Twente University at the Faculty of Science and Technology in the field of electrochemical conversion and materials. I started my research in Erlangen-Nuremberg in Germany, where I did my PhD on how light-absorbing molecules interact with graphene. By understanding interactions between light and molecules, you are able to improve their performance. I then researched at the Lawrence Berkeley National Laboratory during my postdoc to study such light-induced processes for artificial photosynthesis. I was particularly interested in enabling electron transport across membranes, similar to how natural photosynthesis works in a leaf in nature. I'm currently interested in using electricity or sunlight to do chemistry. Specifically, I'm using electricity to convert, for example, CO2 to valuable products such as renewable fuels by doing electrolysis, or I'm using sunlight to convert CO2 to valuable products, which is called artificial photosynthesis. So the way you do it is by taking an electron from water and give it, in this case, to CO2. So you need two reaction sites, one that breaks up water for the electron and one that receives the electron to give it to CO2. So now what combines both approaches is that I am particularly interested in bringing both reaction centers very close together in a way that they do not encounter any efficiency losses. And for this you need a membrane in between the two sites. In my ACCM project, I developed new membranes that can be very efficient in this process. In order to bring the two reaction sites, the one that breaks up water and the one that gives the electron to CO2, closer together, you need to use membranes to avoid crossing over of degrading compounds. So this membrane needs to be very selective in what it lets through, because it needs to let through something while it blocks everything else. So now in the TOPPOP project, we study the innovation path of these ultra-thin nanomembranes. We know that my laboratory work is of course not isolated from the outside world, so it's important to know what takes place outside. For example, what are the relevant market values, political values and societal values. So all these factors influence the future of nanomembranes, and what we want is to understand this influence. But we are not only interested in understanding the interaction between the lab and society, we want to be able to apply this knowledge as strategically as possible within the scientific process. So not just to go outside the lab, but come back into the lab and apply what we have learned outside. And we do this from the perspective of responsible research and innovation. For me personally, the collaboration with social scientists is not only an opportunity to get a broader, more complex view of the world of electrochemical conversion and materials, but it is also great to get familiar with the jargon and methods of responsible innovation.